I have drawn a graph. Let us name it A, B, and these are VT, velocity along y-axis, time along x-axis. Now let us mark origin to be O, and this is initial speed u. I am drawing a perpendicular to represent final velocity v. This represents angle theta, slope of the graph AB. Now we want to do first s is equal to ut plus half at square. We have to prove this graphically, and there should be a second equation, v square equals to u square plus 2as, this one. Now let us shift the graph here so that we get enough space. This is small v, final velocity. So s equals to, as we know, area under the VT graph. So area under the graph, this is the graph, and area under this line AB is this one. So we have to find this area of what? Area of the trapezium, and name is ABDO, this one. Now this area can be found by the formula S equals to half sum of the parallel sides into their perpendicular distance or distance. Now from the graph we see, let me make the graph a little smaller. From the graph we see that half into sum of the sides are u and v. See, this is u and this is v. Let me change the color. So this is their perpendicular distance t, this distance. Now half into u plus, in place of v we can write u plus at into t. You understood this? V can be written as u plus at. Now equals to u 2u plus at and outside bracket t equals to u plus half at into t. Why? Because half into these two. So it equals to ut plus half at square. So s is equal to ut plus half at square. Now let us look at the total picture what we have done. So this is it. So let us learn what is this important formula. Formula is derivative of t to the power n will be n t to the power n minus 1. Look at this. The power n comes before the differentiation formula, and then the power 2, that is the power, decreases by 1, that is n minus 1. So remember it, n into n minus 1. Let us have an example. Suppose the differentiation of t to the power 6. Look at this. Power comes first. 6 comes first here. Then look at the power of t. Second part. Power of t should become 6 minus 1. That is t to the power 5. So 6 into t to the power 5. Now let us take another example. Differentiation of t to the power 12. First part, power comes first 12. Second part, power decreases by 1, t to the power 11. Third example, root t. First write root t in the form of to the power half. Then to the power half will come first, say this. And then the power of t will decrease by 1. So half minus 1 means minus half. So half into t to the power minus half. That means half into 1 by root t. You know this. Now addition or subtraction or both. If we find long expressions, so we will treat each part separately. Now what does that mean? Separately. Let us take an example. Suppose ddt of t square plus 5t. Here t square and 5t we should treat separately. How? ddt of t square plus ddt of 5t. So t square, we will take it first. Differentiation of t square. It would be 2 into t to the power 2 minus 1, that's it. So it would be 2t. Now, ddt of 5t. Here, 5 is a number. So 5 into differentiation of t with respect to t. That would be 1 only, dt by dt. So it would be 2t plus 5. Now, let us do this thing. ddt of t to the power 4 plus t square divided by 2. Now t to the power 4, treating separately, will give us 4 into t to the power 4 minus 1, that is 3, plus t square by 2. Here half is a constant, then remains t square. So t square, that is 2t. How? See here, we have already done this. Anyway, so it becomes 4t cube plus 2 and 2 cancel, t only, 4 t to the power 3 plus t. Let us now do this expression. Say 5t to the power 6 plus 3t square minus 0.5 by root 3 into t. How intimidating. So it is 5 into t to the power 6 differentiation will give us 6 t to the power 5 plus 3 constant, t square 2t minus this part. Very easy, 0.5 by root 3. It will remain like that. And differentiation of t, we did it once earlier, 1 only. So the final result comes at 5 into 6, 30, t to the power 5 plus 2 into 3, 6 t minus the constant part, 0.5 by root 3. That's it. Trigonometric functions are also important. But right now, you need to know only two relations. The ddt of sine t equals to cos t, and ddt of cos t is minus sine t. Yes, minus sine t. These two are important relations. Just remember up to this. Later we'll be doing other relations. Now comes chain rule. This is very important, I would say, but at the same time it is easy also. There is only a certain trick that we need to apply, but it would be applied in most of the sums that we will be doing later in physics or in maths. But before we start this new rule, chain rule, let me ask you one important question. Changa to. So let us take here differentiation of 3t minus 92 whole to the power 10. 3t minus 92 is to be considered to be a single expression. So we know this thing that if something to the power 10 is there, then on differentiating, it will give us something 10 into something to the power 9. The power comes first and its power reduces by 1. So here 3t minus 92 whole to the power 10 will give us 10 that much to the power 9. Then into going inside the bracket, we will differentiate each term. So here 3t minus 92. Differentiate each term means 3t will give us on differentiation only 3, because differentiation of t will become 1. So it is 3 minus 92. I have written here plus. Ignore that because the result is going to be the same. 92 is a constant here, so its differentiation will be 0. Remember this important thing, the differentiation of a constant is always 0. Why? because it does not change with time. I mean, with anything. And differentiation means nothing but rate of change of that quantity. Now, if it is a constant, the rate of change is zero. So it became a little clumsy. Let us do this again. And now try to understand the two parts. So ddt of the expression 3t minus 92 whole to the power 10. So it was 3t minus 92 whole to the power 10. Now differentiation of this will give us 10, 3t minus 92 whole to the power 9, step 1. Then going inside the bracket, it will give us 3 minus 0, step 2. So in step 2, we go inside the bracket and differentiate the expression separately, each term. And in step 1, single expression and then applying the basic formula, n into n to the differentiation to the power minus 1. Now 10 into 3 gives us 30, then 3t minus 92 whole to the power 9. Let's understand this chain rule with the help of example 2. It is ddt of 1 by t plus 5. So let us make first t plus 5 to the power something, that is to the power minus 1. 1 by x equals to x to the power minus 1. Now keep it aside and let us move forward. So something to the power minus 1 will give us something to the power minus 1, and then power reduces by minus 1, so minus 2. And then going inside the bracket, differentiation of t is 1 and 5 is 0. So step 1 and step 2. So equals to, it would be minus 1 into 1, that is minus 1, and t to the power minus 2 t plus 5, that means 1 by t plus 5 whole square. So this is the result, minus 1 by t plus 5 whole square. That is the result of this differentiation. So we are applying chain rule. This part gives this thing. Now for the important sums, change the color. D by dt of sine t is cos t, we know that. But d by dt of sine 5t, that means 5 times of t, then it will not be done directly. You have to apply chain rule. Why? Because there is 5t and not t. That means this formula cannot be applied directly. It's 5t. So we'll do what? We'll apply chain rule. ddt of sine 5t. First, think it is a single expression. Sine of t like thing. If there was sine of something and then we had to differentiate it, we know it becomes cos. Remember the story of two brothers? Sine becomes cos. So let us write sine 5t to be equal to cos of 5t. Okay, but we have to go inside the bracket, that is 5t. So after differentiating 5t, we will get 5 only. These are the step 1 and step 2 respectively. Now cos 5t into differentiation of 5t, 5. So it finally becomes 5 into cos 5t. Here you can notice one thing, that constant term, that is the number here 5, that comes as an extra thing, because sine 5t should have been cos 5t. It became 5 cos 5t. Similarly, ddt of sine omega t, if omega is a constant, it will become omega into, then sine 5t becomes cos 5t. I mean, sine omega t becomes cos omega t. And omega comes as an extra. But obviously here omega is given to be a constant, obviously. Later we will find this in sound, SHM. Now, let us be back again. ddt of suppose sine cube t, sine t whole to the power 3, sine cube t equals to how much? We cannot do it directly. Then chain rule. So ddt of sine t can be written as ddt of sine t whole to the power 3, sine cube t whole to the power 3. So 3 into sine t whole square, first part. Then ddt of inside the bracket, that is sine t. So equals to, this part is easy. Step 1, you can match it with step 1. And in step 1, we knew that ddt of suppose t to the power 3, it should have been 3 t square. Now the second part, that is step 2, that is ddt of sine t. So 3 sine square t into ddt of sine t will become cos t. So we can write the answer here. The differentiation of sine cube t should be 3 sine square t into cos t. This is the answer. So you can do it directly. Think of it, practice it. And let's do one last. Okay. So d by dt of cos cube 60. Now see this, what happens. How much? You can pause the video and do it by yourself. Otherwise, see this. First, we will consider cos cube 60 to be cos 60 whole cube at that, equals to the power 3 means, consider this to be a single term, whole to the power 3. 3 comes first, then the power becomes 2, decreases by 1. So cos square 60, cos cube 60 will become into, going inside the bracket, we will get cos 60. Differentiation of cos 60 will be minus sine 60, again into 6. Why this? Because differentiation of cos 60 is not cos t, it's cos 60. So we had to again go inside the bracket and get 6. Now, this results into minus 18 sine 60 into cos square 60. Hope you understand this. How to apply this in sums? Suppose this is a sum, v equals to 5 root x. Here v is velocity, x is displacement, and you have to find acceleration. So if we apply d by dt of v equals to acceleration a, then we can do this following this. A equals to ddt of v, and v is 5 root x. So ddt of 5 into x to the power half. Root x means equals to 5 comes out. Then half x to the power half minus 1, that is minus half. So I think you understood this differentiation. Then into dx by dt. This is the part you need to understand. See here, t and x are not same. These are different. So whenever you find different quantities to be differentiated, then you need to do this, an extra thing. So let us go through this differentiation, and this dx by dt becomes v. So 5 by 2 x to the power minus half into v. V means this was given 5 root x. Now root x means x to the power half. So 5 into 5, 25 by 2 into x to the power 0, half minus half. So answer is 25 by 2 x to the power 0, that is 25 by 2 only. But we know another formula or method of doing this. How? Acceleration equals to v dv by dx. Do you remember this? Other will see this later. So anyway, let's put the value. V means 5 root x. Then dv by dx means ddx of v. V means 5 root x. This v is 5 root x. So it is 5 root x. That means x to the power half into ddx of 5 root x again. So half x to the power minus half into 5. So the total answer becomes 25 by 2. And x to the power minus half, x to the power plus half becomes 0. So that is the answer. Now more examples. Here we are not doing chain rule all the time. Here we are concentrating on different sums that may appear in physics, where we will apply this calculus, differentiation. So this is the sum. See this, pause the video and try to do it by yourself. X is given and you have to find acceleration. So let us first find velocity as dx by dt equals to ddt of x equals to ddt of x means this was given as x 4 root t plus 23t, or v equals to, after differentiation, see 4 root t means 4 into t to the power half and plus 23t. You have to first arrange them like this, t to the power something, then you will differentiate it. Now it's easy, 4 into half into t to the power minus half, we did it earlier, plus 23t, differentiation of t is 1, so 23. We have done this earlier. And differentiation of t is 1, that's why it is only 23. This is also done before. So the result becomes 2 and half cancel as 2. So 2 into t to the power minus half, that means divided by root t plus 23. We got velocity now. So acceleration can now be found as dv by dt equals to ddt of 2 by root t plus 23. Again, you need to change this, t to the power minus half and then 23. So it is 2 into minus half t to the power minus half minus 1, that is minus 3 by 2, plus 0, 23 differentiation is 0. T to the power minus half gives us t to the power minus 3 by 2 half. See this, half comes first, then the power of t decreases by 1. So minus half into t to the power minus 3 by 2. That's why it became like this. I think you understand. I understood this. And 23 differentiation is 0 being a constant. We did it earlier. Explain this. So acceleration is finally given as minus t to the power minus 3 by 2. That is it. Now try this. You can consider this to be applications of differentiation in kinematics. Actually, we want to do kinematics. Here v is given as 3t square plus 8 meter per second velocity. You have to find acceleration, but at the time when t equals to 2 seconds. You may pause the video and find the answer. So here you go. The solution is v equals to 3t square plus 8. Now acceleration is given by dv by dt equals to d by dt of 3t square plus 8, that is v. So d by dt of 3t square plus 8 will give us, first we will differentiate 3t square as 60 plus 8 as 0. 8 is a number, means constant, and 3t square is 60. You understand this, I think. So the answer is 60. So acceleration is 60. That means it depends on time. Time to time it will change. Now acceleration at spatial time, 2 seconds. See here, you have to find acceleration at 2 seconds. Now let us put 2 in place of t. So 6 into 2, that is 12 meter per second square. Let's revise these things, whatever we have learned earlier. So remember this, d by dt of t to the power n, n t to the power n minus 1, d by dt of constant equals to 0, d by dt of t, dt by dt, that is 1. Fourth is d by dt of sine t is cos t, and ddt of cos t is minus sine t. But let us learn a new formula, that is ddt of log t. So this is new. ddt of log t is 1 by t. Log gives 1 by. Now next we learn chain rule. We'll be learning that again. And then UV method. What is that UV method? We'll be learning. One thing I didn't clear earlier, that is this one. Consider this to be a new thing. We are differentiating x to the power n with respect to t. So you can easily understand that these are not similar, not same. So you have to apply chain rule. How? ddt of t to the power n will obviously become n into t to the power n minus 1 because t and t were same. But here ddt of x to the power n x to the power n minus 1, normal formula. But you have to do this extra into ddt of whatever is inside the bracket, that is x only. Whenever there are two different things, one normal formula apply, then into, just like chain rule, do ddt of or whatever is there differentiation of the thing inside the bracket. When different quantities are there. Let us understand this with an example better. ddt of x cube, t and x are different. So let us put normal formula for x cube, 3x square. Then into the extra part ddt of x. So it becomes 3x square dx by dt. Similarly, if we do ddx of say t to the power 5, 5 t to the power 4, normal formula, then into ddx of t. Try to understand this extra part. Pause the video, try to understand this. And this is the normal part. So try to understand this normal differentiation formula, then extra part. That is what is meant by this. Whenever you find two dissimilar quantities. So let's move on. You have to take note of another thing that I didn't explain earlier. That is, if x is displacement, v is velocity, and a is acceleration, then we know these formulas. What? If we differentiate x, we get v. If we differentiate v, we get further of velocity acceleration. But acceleration has got another identity, v into dv by dx. Let me adjust these things. Oh, get away. Oh, let me draw this. Now, how does this happen? v dv by dx equals to a, see this, we can write v as dx by dt, as we know it, that dx cancel out. So dv by dt is what, a? That's why it is a. What is this UV method? So if there are two different variables present as a product, different variables means, suppose one is algebraic function, another is logarithmic. One is algebraic, another is trigonometric. We'll come to that with an example. Let us understand this. UV method. Differentiation of u dot v equals to u dv plus v du. You can remember this formula, u dv plus v du. What is the meaning of this? Let's see with an example. ddt of, suppose x square algebraic function into, okay, let me change this, t square into sine t. Understood why I changed it? T square, that means t, and here ddt same, so no extra problem. Anyway, so this is algebraic and this is trigonometric. These two are different quantities, so we cannot combine them to different quantities. So what to do? We will u dv and v du. That means what? We will keep u and v as these two quantities and then try to apply this. We will keep u intact, unchanged, and then we will differentiate the second one, plus we will keep the second one unchanged and differentiate the first one, that is t square here. So it will become t square cos t plus sin t into 2t. T square differentiation will become 2t. That easy it is. 2t sin t. See this to confirm your confidence. T to the power 4 into cos t, again algebraic and trigonometric. T to the power 4 unchanged, cos t minus sin t, plus now cos t unchanged, t to the power 4 is differentiated as 4t to the power 3. I think you understood. If you haven't understood everything, that is quite common and natural, and I would suggest you to go through the video part by part and practice the sums that are given in the examples by yourself. Otherwise, we'll be doing this when we face problems in physics. Okay, all the best then.